And welcome everybody to the Daily Space Weather. Today we're talking about a coronal mass ejection, a massive electron anomaly, earthquake off the north coast of Hawaii's Big Island, and how there is zero competition for our channel and zero competition for our solar forecasting. So first thing we're looking at here is sunspot 2835. It's about to set. It's degraded a little bit in its magnetic complexity. It still is considered a beta class sunspot, I believe. Further analysis of that toward the end. Sunspot 2839 has degraded here over the past 24 hours, and 2837 has evaporated entirely and then reformed. Not sure if that one will receive a different name or not. Not really too concerned about it. And let's take a look at the relevant data here from Stereo A. It's a little bit old, but here's the coronal mass ejection that we forecasted in yesterday's video. So we actually included it in the title and the thumbnail, CME Watch Coronal Mass Ejection, and there it is from the perspective of Stereo A, located out here at Lagrange point 5. Let's take a look at Lagrange point 1, the location of the LASCO C2. And it certainly looks like that coronal mass ejection will miss Earth to the west. It is associated with that sunspot that spontaneously appeared and produced some M and an X-class flare, sunspot 2838. It's coming out of the northwestern limb of the sun, expected to miss the Earth well to the west. Continuing on, here's the colorized magnetogram from the Solar Dynamics Observatory. So the most relevant sunspot later in the day today will be sunspot 2839. We'll be keeping an eye on it. And when I say eye on, well, the pun is intentional. Here's some more imagery in 131 angstroms. And you can actually see the likely location of that coronal mass ejection was up here. Again, out of sunspot 2838, which is out of our view. And we'll zoom in a little bit on that. 131, one of the crowd favorite wavelengths. Here's a diagram of the solar system. If you're wondering where stuff is, that's where it is. We'll advance it 1 week to show you where it will be in 7 days. Approaching a new moon here. There's where stuff will be on the 13th of July. The radio flux has dropped down to 89. And if you're a new viewer, you may not be aware that the sun puts out radio signal which is proportional to sunspot activity. So this radio signal comes from the upper chromosphere and the lower corona, and it's at a frequency of 2800 hertz. Here's a 1-year chart of it. The black line is the radio flux, the red line is the sunspot number, and look how proportional they remain. No solar storms forecasted by NOAA here. This is from the Space Weather Enthusiast dashboard. There's your KP index forecast. No geomagnetic storms or unrest or anything like that forecasted. Let's take a look at seismicity. The past 90 days have featured an incredible drought of 7+ magnitude quakes. So you can see only one 7 magnitude quake in the past 90 days. If you're in an earthquake-prone zone, please have a plan to be an asset, not a liability, in the event of a disaster. Earthquake droughts tend to end in earthquakes. And I'm not sure what's going on with the list, but here's one of the largest quakes of the past 24. This 5.2 magnitude occurred north of Hawaii's North Island there. There's a location of that 5.2 magnitude quake. Just off into the Pacific Ocean there, north of Kohala Forest Reserve. Let's go back to the list from USGS. And here's looking at the past 24 hours. We'll just scroll up the list here, citing anything out of the ordinary. It is an earthquake swarm at Hawaii there. There's also been an earthquake swarm in southern Alaska. Leave us a comment, Brett, if you felt any of those quakes. Also, Fiji saw a 4.9 at extreme depth, 541 kilometers. Is the estimated depth of that 4.9 magnitude quake. That 5.2 that struck Hawaii, That happened just before midnight at 23:43 Universal Time, estimated depth 26.9 kilometers. And continuing up the list, a few small quakes in California as well struck. Leave us a comment if you felt those. Leave us a comment if you felt an earthquake, period. Now, I've never felt an earthquake, despite being in several here in Lehigh Valley, Pennsylvania. There was also a deep quake near Hokkaido, Japan, at a 4.5 magnitude, over 240 kilometers estimated depth. Volcanic activity breakdown. Here you go. Suwanosejima has exploded, produced a volcanic ash cloud of unknown size. Tall, on the Isle of Luzon in the Philippines, has calmed down a little bit, having produced record sulfur dioxide emissions. We talked about it in yesterday's Daily Space Weather video. So a significant reduction. It's only producing about 1/4 as much sulfur dioxide as it was in the past 24-hour period. Still producing a 10,000-foot plume of volcanic ash, though. Luatolo and the Lesser Sunda Islands exploding as well. About an 8,000-foot ash plume above it. Beware of ballistic impacts of volcanic bombs and pyroclastic flows and lahars that could affect an area 3 kilometers from the crater. Semeru on East Java also exploding, 14,000-foot ash plume there. Popocatépetl, surprisingly low activity, although some volcanic tectonic earthquakes occurring there, and some degassing. Fuego in Guatemala, volcanic ash not observed in satellite. Don't assume it's not erupting. Rincon de la Vieja on Costa Rica, phreatic eruption there, produced a 12,900-foot ash plume. Phreatic eruptions are when water explodes as steam makes things get out of its way, including rock. Nevado del Ruiz exploding, flight level 200. It's producing a 20,000-foot ash plume. Sangay exploding over Ecuador, producing a 22,000-foot ash plume there. And Sabancaya producing a 23,000-foot plume of volcanic ash over Peru as it explodes. A great reminder to not pole vault the caldera. Please don't pole vault the caldera, and please do pick up some merch. You can find our merch links at smAshomash.com. smAshomash.org will relocate you to smAshomash.com, which we're using to fund our Science Foundation. Thanks to everybody who contributes. Let's get back to GOES-16 data. So the GOES-16 has instruments that face the Earth, as well as instruments that face the Sun. Here's some data from some of the Sun-facing suite of instruments, the GOES X-ray Flux. There was a C-class flare over the past 24 hours, as well as a B-class flare, a sort of a long-duration one. Anyway, that's the 3-day chart. No major flares. The possibility for an M-class flare is still somewhat there, folks, mainly from sunspot 2839 in the northeast. Here's the GOES proton flux. No spikes in that. No coronal mass ejections likely to be headed Earth's way. And here's the GOES magnetometer. Now we're moving into the realm of magnetic data. And you see some extreme spikes here. Earth is quite close to a North Pole-oriented current sheet right now, and we'll show you more on that in a minute. That's the 3-day chart of the GOES magnetometer, looking very spiky here in the past 6 hours. So here's the polarity of the heliospheric current sheet. It's the GONG-2 data derived from 51 ground-based magnetometers. It's the National Sunspot Observatory, and this is one of the most important pieces of data you could possibly have on solar activity. It does have high predictive value, and it gives us insight into what's going on, even on the far side of the sun with magnetometers. Stereo A and B are also shown here if you're a new viewer and you're not aware of this. Stereo A and B's magnetometers are also used in the gathering of this data. So this is stereo A out here, and this is stereo B over here at Lagrangian 0.5 and 4 respectively. And we're expecting Earth to remain in a South Pole current sheet for the foreseeable future. Keep in mind the magnetic environment can change with absolutely no warning, something we say regularly on the channel, since it's the truth. Here's the line of sight ecliptic plane field plot, the same data basically. Again, we're expecting Earth to remain in a South Pole current sheet. This shows the magnetogram as well. Here's the line of sight coronal hole plot showing the sun's B field in blue. as well as coronal holes, South Pole-oriented ones in red, North Pole-oriented ones in green. Let's continue on to look at the coronal hole detected, ASSA coronal hole detected areas and detected sunspot groups. So sunspot 2839 has remained mostly stable. It's degraded a little bit, reducing the likelihood of solar flares a bit. Keep in mind 2835 is approaching the limb, and we see the biggest flares when sunspots are at the limb. We won't get into that mechanism on this daily space weather video. We'll save that for a cosmology segment, which we're planning with Mr. Bagashov. So here's the KP index, a measurement of global geomagnetism over the past 3 days, and we're seeing calm conditions. A KP of 2 is the current situation. And let's look at the real-time solar wind. So here's the solar wind data. We just saw some big shifts happening in the BTBZ in the past about 10 hours. That's something to keep an eye on, that top pane there, the BTBZ, the total field, and the orientation to a pole. Phi angle also shifted with that shift in BTBZ without a major shift in the solar wind density. Current density is just under 10 protons per cubic centimeter. Solar wind speed 340 kilometers per second. Fairly low levels of solar activity here. We just did see a rise in the plasma temperature as well, at the same time as we saw this shift in the BTBZ and the phi angle. It was also accompanied by a mild uptick in solar wind speed. Very mild. Next, looking at magnetohydrodynamic pressure in the geospace. It's the space weather modeling framework. It should be 4 hours of data if all goes well. And we're seeing a fairly steady and homogeneous magnetohydrodynamic pressure on both the sun and non-sun facing portions of the planet. Here are ground magnetic perturbations. And we are seeing some fairly anomalous ground magnetic perturbations here, changes to the Earth's B field. That's what geospace delta B is. And we see these significant perturbations happening down here south of South America, south of the Atlantic Ocean, and south of South America, in this area where my pointer is. We've documented it hundreds of times on the channel. And that's the magnetic section. By the way, twitch.tv/smAsho is a great live streaming platform. We love streaming live to Twitch because it's such a good platform. We'll actually be doing it today for our meteorology segment. Let's get on with it. Also, we are on YouTube, obviously. This video is a YouTube exclusive. If you're new to the channel, press like and subscribe. Press the share button. Tell your friends and foes about our channel. Nobody else does what we do, probably because they can't. We're also on BitChute. As we approach 500 subscribers, we also have a Discord channel. You can link to this. There is a permanent invite link on our homepage, smAsho.com, as well as links to today's featured product. So today's featured product is the Smash Survived Classic Tee in purple, which I'm actually wearing right now. Let's see if you can see it. It says, "I've survived a global pandemic so far." And it's got the Grim Reaper motif and a giant coronavirus and so on. Again, you can find the link to that at our homepage, smashomash.org. We'll redirect you here, smashomash.com. It's the smAsho store. And that's today's featured product. Today's cosmology segment will be integrated into the daily space weather video. It'll be short and sweet. Check it out. Saturn's moons. It's got 82 known moons, and one of them has a massive orbit. That is Iapetus. Iapetus is this extremely lengthy orbit out here, going off the frame, actually. Yes. Saturn's moons is the astronomy picture of the day from apod.nasa.gov. And by the way, yesterday's cosmology segment was a separate video featuring information about AU microscopii. You may want to watch that. It's kind of important, and we'll be talking about AU microscopii in future videos. And that's today's cosmology segment. We kept it short because there's more space stuff to cover. So we've seen some massive electronic anomalies, and we're seeing some minor charging hazards as well. Some charging hazards caused by electron flux here, charging up the surfaces of satellites over places like northern South America, the Caribbean, and Mexico, about to move into the north central Pacific. Here's the 1-year chart of the relativistic electrons surrounding planet Earth. These are measured at the F ionosphere layer, by the way, which is around 300 kilometers of altitude. More on that later in the video. And here's your 3-day chart from the GOES 16. So the GOES 16 in geosynchronous orbit uses radiography to measure the electron content at the F ionosphere layer. There's the data from that, moderate levels here. And we're seeing, here's the forecast for the electron flux. Nothing to write home about there. I won't refute or really even comment on that. There it is, the green boxes of the forecast. The yellow diamonds are the observations. So here's the total electron content forecast, and you're going to see massive anomalies down here. Massive anomalies here south of Africa, south of the Atlantic Ocean, and south of South America. I'm going to rock that back so you can see that in better detail. Check it out. Massive electron anomalies down here. So this gives us insight into the Earth's magnetic field, folks, as electrons have a very low mass. And the only reason electrons would be doing that, short of nuclear weapons being detonated in space around that area, would be because of changes to Earth's magnetic field. So there are changes to Earth's magnetic field happening around the South Polar region. It doesn't get any clearer than that. Yes, electrons giving us insight into Earth's magnetism. Anyway, I'll let the whole thing play through another time, as this is featured in our title, as well as on today's thumbnail. Massive electronic anomalies happening there. And quite chaotic looking electron belts indeed. So here's a diagram of the atmosphere. Those are Earth Van Allen belts. We show it daily to help people visualize what it is we're looking at. And the F ionosphere layer is located just under the low Earth orbit of the International Space Station. And here is the ionosphere. So what you're looking at here is one slice of the atmosphere. The total electron content is the whole air column. The ionogram that we're looking at here is just 300 kilometers, the F layer. So here's that. And we're seeing continued anomalies here over South America and the South Central Pacific, mainly South America. So this is the entire day of data here in ionogram format. You're looking at vibrational frequency in millions of vibrations per second, otherwise known as megahertz. And that's the section on the F ionosphere layer. All right, so we just did today's meteorology segment. Make sure you check that out if you haven't. Here's a teaser. It's the U.S. water vapor map. Here come bonus features in the form of the latest imagery here from, this time, Learmonth, Australia, the ground-based solar observatory. Quite a bit of filaments still on the sun here. You can see all these dark areas down here. Those are filaments. There's a filament up here. Also a filament right here. Although today, no forecast for coronal mass ejections like we did yesterday. Here come additional features, but first I'd like to thank our patrons. Our patrons are the true source of funding for the content that you see in these videos. Perhaps you should thank them as well. But if not, I'll thank you. Thanks, patrons, for giving us some idea of whether or not we'll get paid to create the content. Patreon.com/smAsho if you'd like all kinds of additional information that nobody else gets to see. Become a patron. Tiers range from $3 to $15 per month. Thanks again to our patrons. And again, the URL is patreon.com/smAsho. And we'll close out the video with some additional solar imagery here. Here is the GOES 16 SUVI thematic map. It is still showing a massive amount of filaments right here in the center of the sun. We just showed you some in the Learmonth hydrogen alpha imagery as well. Here's the latest intensity gram of the closest star. Sunspot 2835 has actually degraded here as it sets, reducing the likelihood of solar flares from it. Sunspot 2837 looks like it's going to degrade entirely, and sunspot 2839 has also degraded. So let's press refresh here. Here's sunspot 2839, looking weak. Still beta class. So solar activity has dipped here, folks. There is the full disk view. And here comes some additional imagery. And here you go. It's the closest star in ionized iron and colorized magnetogram from the Solar Dynamics Observatory. Thanks for tuning in to today's daily space weather video. May that solar wind be at your back. Daily space weather, a normal feature of the Smash News Network. Least busted, name it news.